Actually, in this session, we're going to get a chance to talk with some industry experts, right? Some ecosystem experts, because it's not something we can do alone. So it's not something that Redis is going to be able to claim we can solve all of your problems, right? We wanted to be able to do that. But in actuality, we have to partner. And so we're going to go in depth in an architecture that we've designed together. And so I've actually invited some of our colleagues here. So would you introduce yourself and tell us a little bit about what you do at Dell?
My name is Zafar Mahmood. I've been working for Dell Technologies for the last 26 years in various capacities. My team basically, right now we are focusing on Gen AI. We started with database workloads in the past, then evolved as you know, the constant technology evolution. So database workloads, then we moved on to data analytics. Then the in-memory databases came out, column store from the row store evolution, and then now recently AI. So right now the team is focusing on Dell AI optimized infrastructure and the use cases that we can run on them and educate our customers how to use this Dell AI optimized infrastructure. So that's the focus of our team.
And you've seen, obviously, having been there for over 20 years, you've seen a ton of change,
Yeah.
right? And I think one of the things that's important to call out today is, like, as you're starting to build and actually go into the weeds, and many of you here that are going to be building a Gen AI solution have to keep into account that there are several challenges, right, that still exist. And this is why our kind of partnership is really important. So, whether it's fragmented data, like different data sources that you have to include in the application, or maybe even things like cost.
Yeah, for example, when we think about the use cases for Gen AI, one of the use cases, for example, we have a lot of projects going on at the same time, and we have projects reports and in Confluence pages. We have some of them in our Teams share, all of that. So the use cases that we are considering are bringing all of this data together, push it through a RAG pipeline, and just build intelligent chatbots. And just like this application that we're going to talk about that we built, we call it digital assistant. So we can just query all of those data sources, and it can give you, and in the future with the agentic framework, maybe take some actions also. So these are the evolution of the Gen AI workloads that we are thinking about.
For sure. And I also wanted to, before we jump into a lot of the technology, it's important also just to note that, like, our partnership even goes back for many years, right? Even before the Gen AI wave, we've been working together, Dell and Redis, use cases from caching to session management, all of the things you know and love about Redis. We've been working with Dell for some time. And I like this quote from one of your SVPs at Dell. He says, RAG is going to power applications that allow organizations to make better, faster, and more strategic decisions, putting early and smart adopters well ahead of their peers. So maybe before we jump into the architecture and also bring in NVIDIA too, can you tell us a little bit about what RAG is at the core?
Yeah.
Just simplify it for us.
So we built our digital assistant last year, the first RAG. So it was, we call it, what is it called, novice RAG or?
Naive RAG.
Naive
Yeah.
RAG.
Yeah.
Naive RAG, just a model and data, your knowledge base, and bringing it together. So, but this time around, we worked with Redis this time, and using the features like semantic caching, semantic routing, and the LLM session management. So it looks more real now and real world, real-time RAG. So basically what it does is RAG is retrieval augmented generation. So there are two ways you can customize and use LLM models, right? You can fine-tune them according to your organization's data. For example, let's say you want to use Code Llama model, right? You can fine-tune it to your specific code library. That we did a paper few months ago on that, and it's available on Dell Info Hubs. And the other way is just using RAG, which is much simpler. When we did the fine-tuning of Code Llama, it took a lot of effort. You have to use distributed fine-tuning across multiple GPU. Sometimes not only just within the server, but going across the server using AI fabrics, which are very costly. With RAG, things become much simpler. So you can basically augment your LLM model responses with your customized data.
That's right. And I think it's
so
important.
I think that's the way forward.
For sure. And I think it's important to note, like with RAG too, it's not even just about access to fresh and real-time information and data that might be changing. There's also like a real compliance and sort of security element to this as well, where when we fine-tune models on knowledge bases, that information is essentially baked in. We can't revoke that the model knows about something.
Yeah, there's a cutoff date. Like you train it at certain time and it's done. But with RAG, you can constantly keep refreshing your output to your queries.
That's right.
It's real time.
So we're going to get into the weeds of RAG. And before we do that, I just want to say, Dell, Redis, we've worked closely together, but we've also worked closely together with NVIDIA. So I want to make sure, Farshad, we introduce you and get you a part of this discussion as well. And so would you tell us just a little bit about what you do in NVIDIA and how you're serving your customers?
Sure. So this is Farshad. I joined NVIDIA more than 2 years ago. I'm working on building partnership with startups and ISVs to enable them on NVIDIA accelerator computing platform and go to market together. So NVIDIA is not just a chip maker. We are building a full stack platform for accelerated computing, meaning that you can take like specialized GPUs by NVIDIA like H100, A100, and soon to be like Blackwell chips. And then on top of it, like you have access to CUDA, cuDNN, and on top, in higher level of the stack, we have like microservices, frameworks for training, fine-tuning, and inference of LLMs and building, we are partnering with Dell, with Redis to create, these kind of framework, reference architectures or AI workflows that you can take some, building blocks from NVIDIA and Redis, the framework for platform for data management and Dell to build performant AI applications.
Right. And one of the new technologies that NVIDIA's put a lot of effort into, we all know them, like Farshad said, for the chips, for the hardware, but they've also put a lot of effort into making it easier to actually develop applications that would use a large language model, that would use an embedding model, or even re-ranking models, a variety of different sources. So maybe you could tell us a little bit about the NIM movement, if you will.
Sure. Yeah, so NIM stands for NVIDIA Inference Microservices, which are like easy to use inference microservices using GPU acceleration and scalable deployment of AI foundation models, not only LLMs, but as Tyler mentioned, like embeddings, vision language models, even models, foundation models for drug discovery, that you can run them anywhere, on cloud, in data centers, on-prem, and it's like Kubernetes friendly. You can run them, using some Helm charts. You can run them on Kubernetes, and it provides industry standard APIs, like those APIs that use like ChatGPT uses, or like for Llama models, Meta is releasing Llama Stack, which are like set of APIs that you can interact easier with Llama. So we are providing those APIs as well for Llama NIM microservices.
Yeah, and Farshad, by the way, we have at Dell what's called Dell Enterprise Hub. So basically what we do, our team, we take the we have a partnership with Hugging Face. We take the curated models which are most efficient for Gen AI application to build, digital assistants or chatbots or whatever you want to do, fine tuning or image processing. So we recently took Meta Release 3.1 405 billion parameter model, and we have a blog out there, and we provide all of the NIM framework to do the inferencing, and it's available out there for customers to look at.
Exactly. That's great partnership we are driving with Dell. So I just want to talk to your audience. So as I said, I'm working with a lot of ISVs, and customers, and all of them are sharing three main concerns when it comes to deploying AI applications: usability, cost, and security/safety. And when we were designing these inference microservices, or NIM, we factor in all of these three concerns. Because with NIM, you can run them on your air-gapped environment in the cloud, or on-prem in your data center, so you have control on the data. And also, with integrations with Redis database, and also the AI factory that Dell is building, you can have more flexibility and all sorts of AI applications that you can build, and bringing these AI foundation models to your data that is managed by great features of Redis, like semantic caching, semantic routing, and the old networking and other things that Dell data centers are providing.
Absolutely. We're going to give you guys a lower level look at this here in a second. Before I pull this architecture up, I think I want to highlight that there's going to be a lot of things on the screen, right? And you're going to see a lot of different components. I think our intention here, what we're going to do is we want to be able to walk through it kind of step by step. We're going to call out sort of the different parts. There'll be parts from Dell, parts from Redis, parts from NVIDIA. And I think just keeping in mind, right, there's so much optionality right now. You have so much choice, and maybe too much choice, because there's so many tools, there's so many options. You could go do a search on Google, on ChatGPT, whatever, and you would find a list of maybe 40 or 50 different technologies or frameworks you could start building with. So this is our attempt as kind of a community to put a little bit of, a prescriptive solution out there, something that we've battle tested with customers and even ourselves, eating our own dog food. So we're excited to kind of share this with you all. All right, so what you see up here, a lot of different components, right? Rowan just talked about the Redis for AI features that we've been discussing. But we want to talk through this sort of as a flow, right? So we're going to start with the UI. We've seen chat interfaces before, right? People type in questions, you expect to get some kind of answer back. But maybe, Zafar, you could tell us, once that question comes into the back end, maybe what's important first? What's the first thing we need to consider?
Yeah, so as I said, we did RAG last year. It was just initial stages and without any features. So this time around, our CTI office said, okay, let's try this with Redis. So we have this Dell reference design that we worked with your collaboration. So basically, this is a GUI front end, digital assistant, built with Streamlit. So in the flow, so a user enters a query, right? And we are using one of the first, it hits the, one of the Redis features called LLM session management. So with LLM session management, it now has it keeps memory of all of the previous chat history, right?
That's right.
So it uses that context when a user asks a question. With that context, it basically rewrites the query, which is more, more optimal to proceed further, right? So that is the first step, as we show in this graphic. Rewriting the query according to the user session, previous chat history, and all. So this LLM session manager is a nice feature to have because, for all of the compliance and auditing purposes, it keeps all of the chat history. So if somebody wants to take a look, what questions were asked, what responses were given, it's all kept in the Redis database there. So that is the first feature that we utilize in this RAG pipeline.
I think it's important to say too, LLMs on their own, we like to say they're stateless. They're really smart, but they're also really dumb because you have to provide the information.
It becomes,
in the form of a prompt
stateful
every single time you invoke it, right? And so those models, like we all know about using vector search to find data in a database that might be relevant to a question. That's kind of the vanilla RAG, right? But then the next layer of personalization and quality comes from actually also including context from the actual chat session. So if you go to ChatGPT, I think Rowan mentioned this earlier, and you see all the different sessions that you've asked questions in the past. If you jump into one, and maybe you're talking about how do I fix this poetry environment issue, right? Maybe another one is all about like researching topics for a blog you're interested in. But if you jump back into the context of the poetry environment one, you wouldn't expect it to really care about the discussion you're having off to the side about the blog you're trying to write. So it keeps track of like the context within that.
Exactly, yeah.
Yeah, I especially really like this LLM session manager that Zafar has included and his team included in this reference architecture. Just have a question, when it comes to enterprise deployment, security and safety is very important, right? And just curious, how does it manage, RBAC or role-based access control in this reference architecture?
For sure, yeah. And so this is one of the advantages of Redis Enterprise is that RBAC ACL is built into the database, which makes it a powerful platform that just, again, out of the box from day one, we have a lot of these features that, I'll just be honest, like a lot of the newer AI technologies that are out there are like adding this stuff kind of incrementally afterwards.
So for example, like in an enterprise that this reference architecture is deployed, there is a user from the HR and there is another user from the research development team. Sure. So they shouldn't have the same access, right? So when user A from HR is running, all these queries and it's cached through this session manager, then user B doesn't have access to the all, chat history of the user A, right? And which is very, I think, practical when it comes to enterprise.
And the session management component should be federated in a way where the user that's accessing it, right, like just like you said, shouldn't be able to see what someone else is also chatting about at the same time.
Exactly.
Right? So that's a good kind of deeper dive into memory. There's a couple different kinds of memory, right? Like the traditional short-term memory might be, give me the last like 5 or 6 message exchanges that person A has had with this model. But the next layer deeper from that is actually like a semantic-based session management where we vectorize the conversation as it's going, and we can actually then in real time fetch only the relevant portions of your conversation or of your sessions. And I think that's important to note in the context of like longer context models, and as we build that prompt larger and larger, things get more expensive, things get slower. So this is a way to, with Redis, help reduce some of the cost and speed.
And also for multi-turn, chat applications, I think that's another great use case that you want to do, this LLM multi-turn conversation.
That's right. So managing the session data, managing the memory, what's next after that?
So the next, if you look at the flow, the query, after the query has been optimized based on the previous chat history, it's compared against the semantic cache. So there is, semantic cache is basically vectorized previous query, questions, and it's compared, the new query is also vectorized and compared against what was asked before. And if it's similar query semantically, then it doesn't have to hit the LLM model. It avoids the RAG pipeline altogether, and the answer is given to the user interface very fast, right? So it saves you, as in the keynote it was mentioned, it saves you a lot of money if you want to hit the API. So
that's right.
Even if your model is locally hosted, still in terms of latency, it saves, it improves that. So if the answer is in the cache, it's responded. If not, then it proceeds further towards the next feature of Redis called semantic routing.
That's right.
Yeah.
And actually, just on the semantic cache, I wanted to comment this because Talon's demo earlier was perfect, right? It's this data set of FAQs, questions that users frequently ask. It might be curated by a human. It might be something that's learned and created sort of more dynamically. but that data set of FAQs essentially is an index that could sit in front of a RAG pipeline like this. And so anything that hits semantically similar to something that FAQ index, like you said, you have the opportunity to kind of get around and circumvent the slower pipeline that you have there with RAG. So yeah, let's keep moving. Let's talk about semantic routing.
Let's go to semantic routing now. So now we have, in your organization, you might have multiple data silos, right? So in this, we gave a simple example of our knowledge base on Dell InfoHub, which publishes a lot of technical content. Some of it could be AI documentation, all talking about artificial intelligence. Some of them could be, relational databases, SQL Server, all of the other vendors, all of that stuff, best practices about storage, etc. So we want to, instead of, going through all of them and scanning them, we, compartmentalize those into indexes, right? So we have, so based on the index, let's say the query was targeted towards AI, right? So it will take the relevant route in the knowledge base instead of going through and scanning the whole vector of all of it. And the rest of the process is normal RAG. All of the vectors are ranked, and then you with the queries, the prompt is generated and hits the LLM model and gives you the answer.
Right.
If it's a different route, I think in the keynote it was talked about you could have different LLM models.
Right, different models.
But this is a different approach based on the knowledge bases.
That's right.
So there are two options here. So we did the knowledge-based segmentation.
There's actually another use case too. That's around sort of like guardrails, like a lightweight.
Exactly. Yeah, that's what we talked in the morning. There's a guardrail concept also. That let's say some query comes up which is you don't want to respond to it, you can stop it right there.
Right.
So yeah.
The example I almost always use is like if you have a RAG system and someone comes in and maybe asks like, what is Dell or NVIDIA's opinion on like aliens, or like who should I vote for in this coming election, et cetera? Like,
exactly. Yeah.
Probably don't want to answer that question from the application side. So there's a way to set up these routes that can match on maybe like topics you don't want to handle with RAG and you want to answer more deterministically or maybe escalate to a human.
Yeah, that's a very nice use case. Yeah.
And that's only just kind of like the storm door layer. Like think of that outer door that can catch a lot of things and keep a lot of things out, but also someone really intent on getting in can break through the storm door. So there's actually a couple of other approaches to guardrails that aren't actually in this diagram, but I wanted to make sure, Farshad, you could tell us a little bit about the NVIDIA guardrails technology you guys are working on.
Yeah, so with guardrails, you can control what goes into LLMs, what comes out of it, and you can protect it against like jailbreaking, prompt ejection, as well as you can, manage, the dialog flow in like a multi-turn chat. And then also you can check LLM's vulnerabilities. And last but not least, you can enforce custom compliance. And also one more thing I need to mention, you can also kind of add some checks and balances on, the retrieve chunk in a RAG application. You can check the relevancy of, retrieve chunks from the database with respect to the user query. And as a result, you can enhance the security of your, end-to-end RAG application.
That's right. And in this particular diagram, after it goes through some kind of a semantic routing step or a guardrail step, you see that it actually ends up, hitting the knowledge base still. So this is where the actual core documentation or unstructured data or PDFs, whatever it might be, that's been prepared, that's been chunked and vectorized, it lives in Redis and is indexed there for the actual retrieval step, the R in RAG, if you will. And so once we get through there, it's more, at this point, we've covered most of it, but the last step is still probably the most important part, which is where we actually build the prompt and we send it to the model.
We build the prompt and then we send it to the relevant LLM model, which generates your, response, the response to the query, and it's sent back to the UI.
That's right.
Yeah.
And the actual hardware under the hood here, we're gonna kind of go also and talk about that. But I also wanted to make sure, notice with the LLM and also with the embedding model, this is a place that, again, our partnership with NVIDIA is really important, because with the NIM microservices, this now enables us to have these really small containerized applications that just serve models, and they're really good at that, along with all the health checks and the monitoring,
Yeah.
performance boosts.
So this was built with all open source components, LangChain, VLLM, and etc. But we want to work further on it with 2.0, maybe we want to call it, and add data protection aspect to it. So at Dell, we have infrastructure for all, from edge to data center to cloud, all of those offerings. And we would like to use all of those components. They are optimized for AI, so put in data protection as well, because we have the chat history.
That's right.
We gotta, just in case, we wanna save it and archive it.
And so on the previous slide, can I add? So in those boxes that you see, just those neural networks, embedding model and LLM model. So these are the places that you can integrate NIM microservices. Of course, you can also use managed services. It depends on your criteria, like from chat OpenAI models. But if you care about like security, if you want to protect your data in air-gap environment, if you care about cost, then you can think of using NVIDIA embedding NIM. So we have fine-tuned several embedding models that are at the top of the Hugging Face leaderboard, MTEP leaderboard, and also we are working with like major model developers like Meta, Google, Mistral, to make sure that we package their models as NIM microservices. And actually, yesterday we released our new, fine-tuned models based on Llama architecture that again are on the, top of the leaderboard.
That's awesome. And like as we start to come to the close here, I also want to just point out that this architecture, the flow is really easy to maybe follow and understand, but underneath the hood, it's actually built on a pretty impressive stack. And maybe Zafar, you can just give us a quick walk through this as we start to wrap up.
Yeah, so this is basically the Dell AI optimized infrastructure here. So running on top of 3 R760XA servers, which can take up to 4 NVIDIA GPUs. And we have 3 Dell PowerEdge R660 PowerEdge as control nodes, 3 worker nodes, and with NVLink bridges, those 4 H100 GPUs. We are using Dell networking, 25 gig for all of the data connections. And and Dell PowerStore is used for as a block storage for vector database, for Redis vector database. We're not showing over here also a Dell object scale storage F710, which is used basically to store all of the models and artifacts around the models.
One of the things we wanted to kind of walk away from here was a little bit of inspiration, but we also wanted to know, as a community, can you tell us from Dell and NVIDIA's perspective, like, what does this mean? Where are we headed? And can you just speak to how you're each investing as a company a little bit more in this space and as we move forward?
Yeah, I think that the next, big wave of innovation in AI space is agentic AI, and which means like RAG is great at, reasoning, but it cannot take action. It cannot perform autonomously. So I think Llama started by adding tool calling functionalities to Meta, add tool calling functionality API to their Llama models. I think I can see the trends that everyone is actively adding capabilities to help LLMs can not only think and reason, but can also take actions.
Awesome.
Yeah, from Dell perspective, we're working very closely with NVIDIA. So we have these offerings called Dell NVIDIA AI factories. So basically these are t-shirt sizes for AI exploration, from exploration to scalable deployments to scalable performance. R760XA servers based, which can host 4 GPUs. Comes up, these are all defined configuration that customers can order around services. So if you just want to do AI exploration, it's available. Then if you want to go next step, there are the categories of good and the better in each column. So for scalable deployment, then you have scalable performance. You can go rack scale with AI optimized servers, which go host like 8 GPUs each. So we are looking into that and provide like, they are called AI factories, which can host multiple use cases from RAG to agentic model, AI deployments to building models. Actually, they could become huge, and fine tuning, and we publish all of these use cases and methodologies on Dell Info Hub for our customers to learn and how to use this infrastructure.
Absolutely.
So, yeah.
And I wish we could probably keep and continue to chat about this all day long. We're all going to be around, and so please feel free to come up and chat with these folks. I really appreciate your time. Thanks for being here, and everyone give them a great round of applause. Thank you.
We did it. We made it to the end. Thank you so much for joining us. We hope you got a lot out of today. If you'd like to learn more, we encourage you to either connect with our speakers on LinkedIn, set up a meeting with the Redis team member at the link below, or both. And thanks so much. We look forward to seeing you next time, hopefully in person.